Hi everyone, my name is Vikas. I am from a CSC AML Section T in IRE College. I take the topic Isomorphisms in Graph Theory, a comprehensive review. Introduction to Isomorphisms in Graph Theory. Graph isomorphisms are mappings between graphs that preserve structure. They help in classifying graphs based on their intrinsic properties. This presentation provides a comprehensive review of isomorphisms covering definitions, properties, and applications. Basic definitions of graph isomorphism. Two graphs are isomorphic if there exists a bijection between their vertex sets that preserve adjacency. The concept applies to both simple and complex graphs, including directed and weighted graphs. Recognizing isomorphisms is fundamental for understanding graph equivalence. For mathematical framework, an isomorphism between graphs G and H is a function satisfying adjacency preservation. For every edge must be an edge in H. The inverse function also preserves adjacency conforming the bijective property. Properties of graph isomorphisms. Isomorphisms is an equivalence relation satisfying reflexivity, symmetry, and transitivity. The automorphism group of a graph contains all isomorphisms from the graph to itself. Graph invariants such as degree sequences and spectrum are preserved under isomorphisms. Detecting graph isomorphism. Determining whether two graphs are isomorphic is a computationally challenging problem. Classic algorithms include the Weisfeiler-Lehman test and canonical Labig methods. Despite advances, the graph isomorphism problem remains in the complexity class NP but not proven to be NP complete. Applications of graph isomorphism used in chemical graph theory to identify molecular structures. Applied in pattern recognition and network analysis for structural equivalence. Important in database indexing where isomorphic graphs represent identical data structures. Computational complexity and challenges. The complexity of the graph, isomorphism problem has motivated extensive research in theoretical computer science. Recent breakthroughs include quasi polynomial time algorithms for general graphs, open questions remain regarding whether the problem is solvable in polynomial time or is NP complete. Isomorphisms in special graph classes. Certain classes like trees and planar graphs admit polynomial time isomorphisms test. For regular graphs, symmetry properties can simplify isomorphism detection. Uh, Recognizing isomorphisms in these classes aids in tackling more complex graph structures. Advanced topics and variations. Subgraph isomorphism considers whether one graph is a subgraph of another. Labeled graph isomorphism accounts for vertex and edge labels, adding complexity. Hypergraph isomorphism extends concepts to higher order relationship, broadening the scope. Recent developments and algorithms. The Babai algorithm introduced a quasi polynomial time approach to graph isomorphism. New heuristics and automorphisms, group computations improve practical performance. Ongoing research seeks to improve algorithm efficiency and understand structural properties influencing complexity. Future directions and open problems. Determining the exact complexity class of the graph isomorphism problem remains open. Developing more efficient algorithms for specific graph classes continues to be a key research area. Exploring isomorphisms in dynamic and evolving graphs present new challenges and opportunities. Conclusion and summary. Graph isomorphisms are central to understanding graph structure and classification. Despite significant progress, some computational aspects remain unresolved. The field continues to evolve with new algorithms, applications, and theoretical insights. Thank you.